Our last speaker today is Sean Conway, a cartographer and orthoimaging specialist who graduated from the University of Kentucky with a BA in geography with an emphasis in geographic information system, commonly known as GIS. This refers to the use of a computer, a digital map, or data located in different places. Sean's varied work experiences have stretched from helping doctors analyze the geographic distribution of squamous cell carcinoma cases in Kentucky, all the way to evaluating the efficacy of data gathering techniques that is currently awaiting publication at the Association of American Geographers. Sean brings his extensive and modern technology expertise to a personal passion project that allows him to dramatically enhance vintage maps. His work has been featured in magazines such as the Dutch journal Roeligen, excuse my Dutch pronunciation, translated to Building Lines, the Journal of Science and Policy and Spatial Planning, the Italian magazine The Good Life, and My Modern Met, which I'll share a link to in the chat. By using his formidable skills, Sean transforms these maps into stunning three-dimensional relief maps by meticulously rendering their elevation data. What this means is that Sean has taken the long tradition of map making and applied new technologies to bring the usual two-dimensional experience of exploring maps into new, beautiful three-dimensional art form that allows the viewer a whole new type of interaction with the maps. What's really important to recognize here is that the maps that Sean creates defy the eye because they appear to us as three-dimensional reliefs. But the maps he makes are actually flat and two-dimensional, but we as the viewer experience it as three-dimensional in absolute stunning detail and color. Sean says, he's happy to hear when people tell me that these maps help them to understand or better visualize geographic properties of the earth so you can really see the geological phenomena of change in the topography. Now I'm going to put Sean's Twitter handle in the chat, along with the My Modern Met article, as well as a website called Mureway, where you can explore Sean's maps in all of these areas. At Mureway, you could even perhaps purchase a map that might interest you. I know I recently bought one of Iceland for my mom. My other side of the family is Icelandic, and she absolutely loves it. Sean has also generously created an exhibit on Tom Paper's digital gallery so that all of our members and registrants today could explore and enjoy Sean's work at their leisure and in beautiful, zoomable detail. Please join me in welcoming Sean Conway today.
All right, thank you very much. Can you hear me okay?
Yes, I'm trying to spotlight you. Let me remove mine. And I'm looking for it. There you go. It's not letting me spotlight you. Okay. Sean, you just start talking and it should just go straight to you.
Okay, well,
Can you spotlight him, please? Thank you.
I appreciate the introduction. I think I'm going to need to get that your introduction, copied and emailed to me so I can put that in my bio. That's better than anything I have. Thank you all for thank you all for having me this Saturday afternoon for me, morning maybe for some of you. As many of you know, replication of real world elements like natural lighting hues, shadows, and even atmospheric haze aren't really, yes.
Sorry, do you have a camera?
I do not, I'm sorry.
Okay.
I only have it on my work computer and I happen to be at home today.
No problem. Okay.
So sorry.
Sorry, go ahead.
Oh, I'm sorry. As many of you know that the replication of real world elements like natural lighting hues, shadows, and even atmospheric haze aren't new concepts to cartography. Hillshade techniques were pioneered, 200 years ago by Swiss cartographers. Hues to simulate warm natural lighting on high peaks and then washed out blues and greens and valleys to show a misty haze. In maps were used by famous Swiss cartographer Eduard Imhoff in the 30s and on into the mid 1900s. What I'm trying to do is recreate these concepts with modern technology. And today I hope to demystify the process a bit and just give you a broad overview of how I produce these maps. This will be more like a demonstration of my process than just a flat presentation. I'm going to share my screen here in just a moment. And again, I just hope to give you an idea of how I make these and the technologies that I use. I'm not exactly sure, how long this will take me. I will be doing these live and switching between applications and rendering some things on the fly. So it just depends on if my computer wants to cooperate with me or not. But let me go ahead and bring my screen up here. Okay, I hope you can all now see just a nice, almost blank white canvas there.
Yep.
All right, and like I was saying, a lot of these things were pioneered by Swiss cartographers as long ago as 200 years ago, or so appropriately, I've decided to use a Swiss map for the demonstration today of Jungfrau, which is one of the main summits of the Bernese Alps. This particular map that I'm going to show you is from 1956. So to start the whole process, the first thing I would do, of course, is source the map. I apologize, I don't remember exactly where I got this map, but I'm sure many of you may already be familiar. I believe I got it from Gallica, which is the French National Library's online viewer of maps. And I'm sure many of you are familiar with that. And if you're not, you would really do yourself a service to check out the maps that they have. They've got so many maps from around the world from many times in history. It's absolutely a beautiful gallery.
Gallica?
What's that? I'm sorry.
What was it called? The name of
It's
the
called Gallica. I'll put the link in the chat.
Super.
All right, so once I source the map, I'll bring it into my GIS here. I'm using Arcgis Pro. There are many other alternatives, but I personally use Pro. A lot of people will use another one called QGIS. QGIS is a free GIS, so if you ever would just like to learn the basics of GIS software, that is a great place to start. Once I have the map in, this map, other than what I see on the screen, has no real geographic reference in the program. So what I will do is what's called Geo Referencing. And in order to georeference, I will often bring up a base map. This is Arcgis Pro's base map in here. You can see this one's already georeferenced, it's already in the right place. But what I would do is to go in here and to begin my georeferencing. This particular map did not have easily identifiable intersections of the graticules on it that I could use to just match it to latitude and longitude. So I used features like summits, as you can see by my points spread throughout the map. Excuse me, I was taking a little drink there. And what I would do is take this map, make it just a little bit transparent, find that summit. I would click on the map where the summit is, and then I would click on the base map where the summit really is geographically. And once I find several points throughout the map is now basically pinned down to the correct geographical coordinates. Turn this off. Once georeferencing is done, I would draw an area of interest boundary around the primary part of the map that I want elevation data for. And that's what I've done here. You can see this is primarily the area that I want the elevation data for. And I would go out and use public repositories for the elevation data. Usually for the US, I would use the USGS national map. They host a lot of data on there in varying resolutions of elevation data. For this one, once I found the elevation data, I would then clip it to just this area of interest that I want. And you can see this is basically what a stretched raster looks like. What a raster is elevation data where each, it's basically an image of the elevation data where each pixel, each cell contains numeric value for the elevation in there. And to get a better idea of what this looks like, I can actually apply standard hill shading, what we would normally do in GIS. And this is what I would get. So this is why it's important to geographically reference the map so that I can get it aligned with the elevation data that I want to displace it within 3D software. And now that I have this line, I can even get kind of a little preview in ArcGIS with their new blending modes. I can take this hillshade and just multiply it here. And now I have that kind of blended with the map, and I can get an idea of how this might look in even more 3D. You can see that the Swiss map, like I said, the Swiss really pioneered the hill shading. Even this map had some hill shading on it. And then we can add even more to that, just giving us an idea again of what this will look like fully in 3D. Once I have that done, one thing I'll often do is do a little bit of color correction on the map here. It's a little washed out, a little yellowed. So I'll usually go through Photoshop and try to bring it back to a more what you may have expected to see when it was originally printed. And this was my version of Jungfrau once I was done color correcting it, giving the glaciers a little more of that blue hue and making the greens pop a little bit more. Once I have everything done in ArcGIS, that's when I would move on to Blender. Blender is a 3D program, and it takes those cell values I was talking about, the raster values. It takes each of those cell values and translates it into a 3D position and builds a 3D model out of it. And so you can see I've already loaded Jungfrau in. And now that I have it in 3D, this is from that exact same raster that we're looking at in ArcGIS Pro that was in 2D. And now it's been translated to 3D using this 3D program. And now we can, we get beautiful views. And as I was saying before, we could use a lot of cartographers would try to emulate real world sunlit hues over mountaintops, or try to make the valleys look like they were in a subtle haze. When I'm in Blender, I can drop in a lamp. It's basically a sun lamp, and I can play with the directionality of the sun, give it any color that I want. But in Blender, I actually generally use what's called an HDRI. That's a high dynamic range image, and it's 360 degrees. So it's basically forming a bubble around my 3D model here.
Sean,
And yes.
I don't know if you're accepting questions, but I'm
absolutely
bursting here with so can you show us what it looks like? Like it looks like right now the sun, the light is like from the upper left corner. Can you show us the same map as if the sun was on the lower right corner?
This is actually a default view in Blender. This has no actual lighting that I've applied to it. And that's why I was mentioning the HDRI. That's how I apply my images. And again, it's an image that can go all the way around my model. And the HDRI is usually of an outdoor scene. One that I'm using here has, the sun in the sky, has a full outdoor scene. And Blender uses the values of the brightness of that image to render lighting for my model, which gives an even more realistic lighting technique, where instead of me trying to, emulate a sun with the exact right colors that I want, I'm using an actual image of an outdoor area with the sun shining to illuminate my model. And let me bring that up. This is where if you have any questions, feel free to chime in now. This is where we might take a second to render this in a preview with that information, with the lighting information in there.
So you originally get the 3D-ness of the image from the topo lines that were in the original map?
No, the elevation data is modern elevation data. There are many, you can do that. You can take topo lines if you want to isolate them, and you can create a surface from that and then render that in 3D. So this is with actual sunlight, rendered with actual sunlight. And again, this is modern elevation data. we can actually see one interesting thing in the map here is you can see the glacier has receded from where they originally had it in the map here. You can see the flow lines from the glacier up through here.
Yeah.
But they actually had it well down here in the original map. When I first posted this map, several people pointed out how much the glacier has receded since the 50s when this map was made. But this is modern elevation data, so it can be quite different. Usually on a large geographic scale, you're not going to notice much, but when you get into like city size or something like this where it's down on the glacier, you can see.
That's the part that's receded.
I couldn't tell. Yeah.
Used to be up here, maybe.
Sean, do that one more time, because I had the same question. I think somebody else does.
voice is
Show us
on.
again the glacier, the size of the glacier in 1950s versus what it is today.
Sure, you can see all the smooth white and blue areas here are where they had the glaciers in 1956. When we bring in modern elevation, it looks as though if you're looking at the flow lines here, it looks
It's
as
the
though
grayish area now.
it looks as though it ends right at this line here.
Wow.
And whereas it used to proceed further down the mountain here. If we look at any other glaciers, I'm not sure if we can see something similar here. There are several in this area.
I expect you could see that on virtually every glacier in the Northern Hemisphere.
I imagine, yes. It's a little harder to pick out. This one just has this very obvious line where a demarcation here in the elevation where you can see where it stops. But I imagine if we got, compared it to modern imagery also, that would even more verify how much it's receded. But yes, so to further answer the question, it is modern elevation data. However, if you do have historic contour lines, a surface can be interpolated from that. We would take that and basically translate it into a raster image instead of the lines. And from that, we can then assign each cell a value, and those cells could be brought in and made into a 3D model. It's something that if, like, say I wanted to see Mount St. Helens, we didn't have the raster of the area then, but we did have contour lines before the explosion, before the eruption. So if I wanted to see Mount St. Helens in 3D before the eruption, I could take contour lines from, say, USGS map from pre-eruption and make a raster surface out of that. So it does have its applications. And now you can see this is with a sun in the northwest, which is very common cartographic practice. But as Tom was asking, let's look at it from a different direction. Down here is my nodes editor. It's how I control things in this 3D, such as the lighting placement, the models, things like that, and textures. This particular one, let me change this around to come from the other direction. And I crashed, I apologize.
Of course. While you're restarting, I'll ask a question. Conceptually, with all due note to Mark Monmeyer, who wrote a book called How to Lie with Maps, I'm curious to know if there are ways that that in these depictions, the truth is altered, or is your work largely one of design and sort of doing something that's aesthetically pleasing? But are there ways that things can be inaccurate in what you do?
Absolutely. And obviously very familiar with the book. It's, sometimes required reading for many people with a geography degree or statistics degree. Also, I believe there's also a How to Lie with Statistics book too. But yes, absolutely. I mean, as we all know, one of the first things you learn when you're learning about maps is that every map is a lie in one way or another. And I mean, what you're looking at on my screen, I'm sorry, let me turn this model on. I was waiting for it to render. I just realized I didn't even have it turned on. When you're looking at this on my screen, one thing I'm already lying to you about is that I've exaggerated the elevation. It is currently at 1.5 times elevation as opposed to what it would look like relative to itself in the real world, just to bring out some of the details.
What does that mean? Is that like having a graph that starts at 100 and goes up to 102, and so it looks like there's a big increase in something?
Yeah, it could be. Basically, I'm taking every one of those values and multiplying it by 1.5. So I've increased the elevation by about 50%. So let me get down here to a little more detail. And the larger area of the map that I'm working on, the more I have to increase the Z exaggeration, the elevation exaggeration. If you're looking at a continent at geographic scale, you almost won't see any elevation changes. If I put a sunlight on it, it'll just look almost like a flat surface. When I'm close in with something like Jungfrau here, it's really not that necessary. The 1.5 exaggeration is just to give it just a little more of a wow factor here to see the details in it. But if I were to bring it back down to its standard elevation, it's not a huge difference. But you can see it's this is relative to itself what it would look like in real world. So that's one thing I'm already lying to you about. And then the sunlight is another thing. While I'm using a sun that looks realistic, I don't always have realistic angles. As you know, where you are in the world will change the angle of shadows. If you're in the north, in Canada, your shadows should be cast upwards.
Right, you're putting equatorial shadows into a different region or whatever.
Right.
Yeah, interesting.
And I generally, like you said, it is more about aesthetics for me. Very standard cartographic practice is to have shading from a light source in the northwest, like I was showing this just a moment ago. And there's reasons for that. Not to get too deep into why that is, but one of the main reasons is perceived elevation inversion. If you have light, or if you have your shadows in any other direction, it's been found that the viewer can sometimes, it will cause them to invert the elevation. The shadows won't look right, and they'll see valleys as hills and hills as valleys. One notable thing that I found about 3D mapping, which I was not expecting when I went into it, is that since these shadows cast into the margins, it fights that perceived inversion of elevation, no matter which way you have the light coming from. So you will, since the shadows are casting off the map into the surrounding area, which we'll see in just a little bit, you can have the sunlight coming from just about any direction, and you should not have that perceived inversion. But let me flip this. Oh, I'm sorry.
I do want to, so we got one question from Doug Olcott, and before I read that, I also want to encourage other folks here to jump in and ask questions. I mean, please, Sean will respond to all questions. I know we've got a variety of technical backgrounds, and
absolutely, especially times like this one is loading. So
well, this can be used.
Doug, you had a question about doing a. I'm sorry.
Yeah, we had a question from Doug Olcott, wondering if we could do a fly-through of one of the valleys on your DEM-based map.
Fly-throughs will be tough, but I've actually animated one that I do have up on my Twitter. I can bring that up here shortly. While I'm waiting for this one to load, maybe I'll do that actually right now.
I think I have it on the digital. Did I have one on the gallery? No.
Thanks, Sean. That would be great. And I put Sean's Twitter account in the chat. I'll do it again. He posts a lot of really great videos of his maps there. And the really great way to see it. And also I see, is that Tim? Tim, do you have your hand up, Tim?
I do, yeah. I'm curious. This can be done in the reverse for ocean mapping, can't it? For the depth of oceans.
I can also bring up an example of that. Actually, there is one that Tom put in the gallery of Hawaii, where I did use bathymetric data to make the so that you could see the surrounding ocean data around the topographic data of Hawaii. And I believe they also Tom also posted an animation of that.
Well, one of the
And
reasons
those
I'm
links are
interested
now
that
in the chat. Those links are in the chat, both for the Hawaii and the fly through.
that's
So
great.
if you can
Thanks
link
so
to the
much,
chat, because they're
Brittany.
oh,
This
sure.
is
And also
fantastic
Fred.
because
Oh, sorry.
for those of us who are interested in trying to graphically represent things of sea level rise to people, this is absolute ammunition. This is fantastic. We got to learn more
Yes.
about it.
Yeah, I've not particularly done anything with that. I've accidentally raised some data before that made it look like sea level rise. I wasn't meaning to, but some other people on Twitter, I've recently been talking with somebody on Twitter who does mapping, also a cartographer named Carl Churchill. And he was trying to map sea level rise in Blender also. So yes, it's absolutely can be used for that. And
I see Fred Auda has his hand up as well. Fred?
Yeah, just quick, sorry to ask you to repeat, but what corrects for the figure ground reversal? You said something around the edge of the image will cause that confusion around perception?
yes, I'll show that here in just a little bit, but right now what we're looking at is just a model of the data. I'll texture it with the map, and around that map it has the collar, the margins. The shadows will then, from just this area, will fall into the margins. And I found that that actually helps with any perceived inversions.
And is the research into that, does it say anything about why that inversion happens? Is it just our brains have gotten so accustomed to the lighting from that direction because it's a standard that we expect it to be in that direction, or is it something?
I don't think I've not really read much into the research on it. I don't think it's because we've gotten used to it, because that's how cartographers have always done it. I think it's the other way around, where cartographers do it that way because we found that we inverted otherwise. I've not read into the research why, though. Also, I love your background there.
Yes, I was already a fan.
Thank you. Okay, so let's see if we can turn this lighting around without it crashing on me this time. So this is from the northwest, and we're gonna go. What I'm doing now is just changing the coordinates of my HDRI, and now that should be from somewhere in the northeast.
Cool.
And if I can rotate this around, you can see it's doing a preview render on the fly. So that's why it looks really pixelated. It'll slowly render in, but you can see there's my sun there. Okay, and let me actually bring this over real quick. So this will be the finished map, which we'll see here in just a moment. But this is a fly through that I rendered of it.
Wow, that's amazing.
This is unfortunately very low quality. I did render it much better quality, but Twitter does not like to compress it, I should say.
The elevation data that you get, every pixel is how many feet or yards or meters or whatever. How detailed is that?
It can vary greatly. Sometimes I even pull down raw LiDAR data, which is, I'm sure most of you are familiar, but LiDAR is basically a plane flying overhead, shooting a laser at the ground and getting very, very precise measurements. I can use that point cloud to produce a raster, and I produce sub-meter rasters with that, where every cell is, can be a half meter, quarter of a meter even. in granularity. If I'm doing something really close in, I will often do that. If you go to my Twitter, you may also see some other maps that I've produced that do have building footprints in them from
Okay.
LiDAR. And that's how I get the buildings. It's with LiDAR data. If it's classified properly, it'll have bare earth and it'll have things like vegetation and buildings classified. So I can make just a bare earth DEM, which is what we're looking at here. This is just bare earth, or I can make one with vegetation and buildings in it. I've made maps with that also. But
And
as
I
far, I'm sorry.
I heard you're thinking about buying a 3D printer.
I am.
Why?
Well, it's just another person for many people to follow will be Dom Riccobene, or I'm sorry, I believe it's pronounced Riccobene. It's Riccobene. He's very popular on Instagram. If you see his 3D prints of topography, it's mind-blowing. He does a really great job. He actually just recently did one of video game topography. It's GTA 5, but he does CNC routing and 3D printing, just a great job at everything. And it's just one of those things where, I'd like to play with it myself.
So you literally could.
So it's
print out
Bertrand
these
Benoit.
maps.
Bertrand Benoit.
I think
sorry.
I found him, Courtney.
Oh no,
Dom,
Riccobene. Never mind. Wrong person. I had the wrong one.
yeah. But getting back to Jungfrau here, let me actually bring up here real quick. I don't remember what the resolution is that I ended up with. One moment. So I can look at the properties here and I can see that it came out to 7.09 meters per pixel. So that's the resolution I'm getting. Every cell on the ground would if you're actually on the ground would be 7.09 meters. And just, of course, the larger and larger map you're doing, the larger and larger that cell would get. But even at 7 meters, you can see we're getting outstanding detail for the level of map that we're making here, to the point where you can easily see the glacial flows. If I can get in here a little bit better. Sorry, I lost my bearing on the map itself.
I mean, I know for me, seeing maps of things places that I've known or thought that I knew, and then I see them with your 3D relief, it just changes my perspective. The map of Europe with the 3D relief on it, and thinking about Hadrian marching his elephants over the Alps. I mean, I could see literally where they were going. I am curious to know what, Sean, other people find to be most fascinating about these maps.
Well, I do also do geological maps. If you look at a geological map with the 3D terrain, it also helps illustrate, those geologic formations. Most geological maps just look flat, but when you have the 3D terrain behind it, you can see, those actual geologic formations. I've had somebody else on that same European map, the tectonic European map, that also had bathymetry in it. And I believe they were like a surfer, and they pointed out they could actually see, since I put the bathymetry. Well, they could actually see, since I put the bathymetry in there, there's this channel that causes, he said, some of the largest waves in the world. And I believe it was in Spain.
Yeah, off of Portugal.
Oh, it was a Portugal.
Nazaré.
Okay. Oh, that's it. Yes. I'm not particularly somebody who's very knowledgeable about surfing. So, but he said that you could actually see the channel in bathymetry there. And I just found that really interesting. People will often point out things that I had no idea about, just general facts from a map. And I just absolutely love that.
Well, if you did it with historical maps, you'd have an extraordinary narrative thread, because you could do something like Napoleon's march into Russia, for example, and figure out what he had to contend with, what his terrain was like all the way, and you could see why people died at certain places in massive numbers.
Oh, that would be very interesting, actually. Yes.
Yeah, but one of the things I've found fascinating as I've explored some of Sean's maps on Instagram is some of the historic maps of cities where you'll have like the state of the city at the turn of the century overlaid with the modern LiDAR or digital elevation data. So you can very clearly see, if it's a coastal city, you can see the infill where, the 3D is clearly showing you that, oh, this area has now been infilled that had been water, or there's now an island here that didn't even exist at that point.
Yes, and I mean, my map of the Netherlands actually obviously really illustrates that, since I use modern elevation data, but the map was from before land reclamation. So where there's a large bay in the map is now, you can see the outline of land reclamation. And
Well,
I even see it in, like I did a map of Louisville with LiDAR data, and where I saw a small, airport in it, with the LiDAR, you could see the outline of a large international hub now.
Well, we're doing this in reference to what's called the post-Columbian city. If you realize how many cities in the New World have been put in place since sea level of 1492, you can see what trouble we're going to have very quickly as a not just a nation state, but all up and down the hemisphere, because we're in trouble. We've been looking
I'm
at this
also
in Boston.
noticing, sorry, Tim. I'm noticing, is it Fred? Do you have your hand up to ask another question?
Yes, I do. Just an observation. I'm not a surfer, but Maverick's break off of Half Moon Bay is one of the most dramatic in the world and one of the most dangerous because of the steepness of the wall itself. And it wasn't until the surfers wondered about it for years as to why they had that unique form. If you read the face of the wall as it breaks at Mavericks, there's a part of the wave at the middle where the sea level is actually lower. There's a dip, like a valley created, that created one of the most dramatic drops in all of surfing. And they didn't realize what that was caused by until they had done the mathematics on the basin, and realized that there was a 45-degree angle that crosses the break of the wave itself when it's a south swell. And so the mathematics actually taught the surfers how to deal with that dramatic drop being one of the most dangerous in the world.
Yeah, it's amazing what we can learn just from the bathymetric data, and seeing it in there. That's why I love these Hawaii maps. I plan on doing more of the Hawaii maps because they have high quality bathymetric data for around the islands themselves. Unfortunately, getting anything away from shorelines, you're going to get the bathymetric data quality kind of drops off because it's either not been captured, and where it's not been captured is actually inferred. A lot of bathymetric data we see today is inferred from gravitational measurements. We're making guesses at what it's going to be, what it looks like just from what the gravity measurements are like in that area, which I find absolutely fascinating that they thought to do measure bathymetry through gravity. Oh, and one more thing I meant to mention, going back to the lighting and angles, that's the other way I'm lying, is again, that's purely aesthetics. I have in the past used, there are sun calculators or sun angle calculators online that you can use to see the exact sun angle at any time, anywhere in the world. And I've used that before, not very often, but I did use it once when I did a map of a landing in Normandy. I tried to get the sun angle exactly like it was at the time. So the next step after we get the model in here is to texture the map with the original vintage map, and that's what we're seeing now. This is the vintage map overlaid with this. This is from what's called an orthographic view, meaning that we're looking straight down on the map from everywhere on it. There's no lean or anything. But we can see now that we have the full 3D model on there.
Ooh.
Wow.
We
that's
can
amazing.
again, zoom into these glaciers. Just follow that around. And again, this is what I was animating in there. It was coming up.
So this
week.
is what you could conceivably, I'm looking at Dom Riccobeni's website. And so conceivably with a 3D printer, you could print this out?
Some of the things that he's done, yes. He also does CNC routing, which he gets a lot more detail from. But say from his Grand Theft Auto 5 map that was 3D printed. But he's done CNC routing in several things. So yes, some of the things that he's done is what I'm hoping to do also. He's experimenting right now with a resin printer instead of a filament printer. And resin is what I'd like to go with also. You can get higher detail out of it. So
have you thought about doing this? Sorry, I'm bursting here.
No, it's okay.
Have you thought about doing this like in a city, like doing this for Manhattan and being able to zoom around a map of Manhattan like this?
I have done Manhattan.
You have.
I used LiDAR data to get the building shapes in there. The issue with that when doing it with a vintage map is that the map will interpolate straight down the sides of those buildings. So it'll look something like the edge of this, like you're seeing right here. It just goes straight down the edge. So buildings look kind of weird when you get sideways on them in a vintage map, whereas the slope, to the hills here looks normal. So my Manhattan map, I did not do a fly through of that because I just only did it from straight above for that reason, because the buildings would look odd from the side. It would just be kind of the streaks of the map. But once we have this textured, we can again.
There's a question here from Julie.
Absolutely.
Hi, Sean. This is really fascinating. I'm just real curious. When you did the animated Hawaiian maps, what program did you use to do that?
That was also in Blender here. Blender is it's 3D, but you have a full camera in there. And the camera acts a lot like a real camera. You can set focal length, depth of field. You can move it around just like a movie camera. So I just moved that camera straight up for Hawaii, I left the camera where it was and I animated the parts. For the Jungfrau one where I was flying up the valley, I moved the camera through the map. For Hawaii, I just left the camera directly above it and I moved the components of the map so it looks like it's filling with water or not filling with water.
Okay, I wonder how many frames did you have to come up with to create that effect?
I generally try to keep it. I render at 30 frames per second, and I try to keep it at 30 seconds or less. The Hawaii one is actually sped up. I did render that at 30 seconds, but it's sped up quite a bit to go back and forth through that same animation. I think Tom, did I send you the one where like the water goes down and then comes back up, or did I send you just the one where it goes down?
In Hawaii?
Yes.
I don't know.
Okay. If it's the water where the Hawaii just slowly raises and then the water just slowly goes down in about 30 seconds, that's my original render. I've since made a newer one where the water goes up and down quickly within about 15 seconds.
Oh, okay. Thank you.
No problem.
Fascinating.
Alan Wolf has a question.
Yes. No, it's not a question. Get a 3D printer, you'll love it.
I have no doubt. I was looking at the details on Jungfrau and I thought, oh, I'd love to 3D print this. I've never been there. I actually never really heard much about Jungfrau before I made this map, but looking at it just looks beautiful.
Yeah, this is Catalina, looking from Catalina up to the mountains in Los Angeles.
And Alan, so what are you doing? Did you make that in your 3D printer?
I downloaded the actual file. I did not create the file, but Blender can create a file that you can then get a G code out of from the 3D printing program and load it into your printer and print it.
Absolutely. I've exported STLs from Blender. I actually recently did it for a coworker to 3D print.
What's an STL?
STL is it's a standard file that you use for 3D printing or 3D or in CNC routing. I've exported one for a coworker to 3D print a volcano recently in the, I think it's called the Lassen volcanic park.
Yeah.
Our company had flown some LiDAR and he wanted to 3D print one of the volcanoes and it came out looking really good.
Cool. Dan Scoll's got a question.
Yeah, first off, yeah, just beautiful maps. I mean, I've spent so much time working with hill shades and DEMs and LiDAR data and geo referencing and all of the above. So kudos for great work. You know, to your point about the visualization capabilities of the hillshade, my research area of the Klamath Mountains, I found it just remarkably elucidating to be able to see these areas that I was familiar with on the ground, and then to be able to read drainages and so forth, and have been incorporating that in my classes with my students. But to a question, I'm wondering what your thoughts are on the 3D capabilities within ArcGIS Pro, since you sort of jumped out of ArcGIS Pro when you were doing the 3D work.
It's great for quick visualization. I don't see the same detail in 3D models in just ArcGIS Pro. Now, Arc does make other applications that you can bring 3D data into, and they are starting, from what I've seen, to incorporate things like HDRIs for lighting and ray tracing in their lighting. Whereas that's something I haven't really mentioned here, is that the way that this 3D software makes the light so realistic is it's actually tracing the light rays as they bounce around on my 3D model. ArcGIS Pro, of course, does not do that. It's meant for displaying the data quickly in 3D, and it's great. I use it all the time when I'm working with LiDAR data. I bring in, I convert it to a local scene, and I'll look at the LiDAR data from there. It helps me pick out noise easier. But it doesn't give you that really aesthetically pleasing look. It is meant for more the analytical side of things. But again, Esri does make other applications that are incorporating the ray shading and HDR lighting and things and it's looking great in there. And there's so many avenues to explore, everything from other 3D programs such as Cinema 4D and Houdini to video game engines. I've really wanted to bring these into Unreal Engine 4, and now even more so into Unreal Engine 5, since it handles high polygon models better, so that people just download it and look around this map, move around it easily. You can see that even, I have a pretty beefy system, and it struggles to move around and look at it with the lighting that I want and everything like that. In a video game engine, it would do it instantaneously. It would look, realistic, and it'll look good, and you can move around the model easily and fly around it.
So is that just a question of just a bigger computer, a bigger, more expensive machine?
No, it's just in the way that video game engines render data that they can do. It's meant so that you can interact with it on the fly. Blender gives me a much more realistic render than a video game engine, but not so much that you can't get it looking good in a video game engine. Also, for somebody to just do it on the fly and quickly fly through it without it looking all pixelated when they move around like this. Yeah.
Hey, Sean, how does what you've shown us today, relate to your day job? Like, does it or does it not?
It does in some ways. There's some overlap, like working with digital elevation models, LiDAR, and things like that was second nature to me, just from what I do.
What do you do?
But primarily what I do is I work with orthoimagery. It's basically a plane will fly and gather the imagery, and then we need to make those images into geographically correct product that looks like one continuous image for our clients, not a bunch of frames like the plane's capturing it as it goes. And to do that, it goes through a lot of steps that most people aren't aware of. Everything from aerial triangulation to make sure that it's perfectly aligned to geographically, to orthorectification to get rid of any distortion in it. Then we can, we seam it into a one seamless model or one seamless product, and things like that. So basically, if you look at Google Earth, you see images of the Earth, or you may be familiar with satellite imagery, like from Sentinel or things like that. What we do is just on a much, we're able to do it quicker than satellites. We can get a plane on site, take imagery, and it's at a much higher resolution than you would get also. And it's my job to produce that imagery.
Cool.
But for the orthorectification process, that's where, I already knew a lot of elevation sources, because for orthorectification, you have to have a digital elevation model to do that. So getting back to, I know we're almost out of time here. Getting back to the perceived inversion, as I was saying before, you can see where the shadow falls outside of the map, or the main area of the map itself, and goes into the margin now. And I found that really helps fight that. I'm actually working on a map right now that I hope to post tomorrow on Guam. It's almost done. I hope to put a few clouds into it, but you can see I went with a northeastern sun angle in that, and you're not
This
really
is
gonna.
so gorgeous, Sean. It's just
Thank you.
stunning.
So you guys are the first ones to see this. I'm not done with it, but yeah, you can see the detail in there with the geo referencing. You can see that this river is perfectly aligned to where it should be on the map. The contour lines follow it. But again, I decided to go with I still generally stick to the common practice of northwestern sun, but with this one, I went with northeast. And my very last point, other than rendering out the map, is as I said, Imhoff tried to simulate ground haze, low level haze, and valleys with washed out colors. But now, hopefully, if my computer doesn't crash on this last one, I can add real mist and fog to a map. And that's what's loading up now. Volumetric data usually takes a little bit longer to calculate, so it's just going to take a moment to come up. But I can, once this resolves itself a little bit, you'll see that some actual mist and fog in the valleys around Jungfrau here. I don't know how well you can see that there, but again, just trying to bring old cartographic techniques into more modern technology. And if I were to come around here. It's a little less responsive when I've got even more things like fog in there, but you can see it down in the valleys now. That's, again, volumetrics is something that I'm also going to be adding to this Guam map before I post it tomorrow, is I want to put a few clouds over the ocean. Again, only for aesthetics. Generally, like in my day job, we do our best to get rid of atmospheric haze. We don't want any clouds in our data. Our pictures need to be perfect. But then when I come to make these maps, I'm putting in atmospheric haze. I'm putting in the clouds again. So it's kind of the opposite of what I do for my day job. And from here, I would just render this out. Maps can take anywhere from 1 hour to, if I've got really complex volumetrics in it, could be half a day. Animations usually take 2 to 3 days to render. And that's basically it. If there's any more questions, I'd be happy to field them.
Thank you so much, Sean. This has just been so fascinating. I mean, for someone like me who's not a techno expert, my mind is kind of blown. Tom is just like flowing along and
Also
understands
blown.
everything,
No, also
but
blown.
knows what questions to ask. I mean, this is so above my pay grade. I'm just trying to take it all in and understand it. And I love that we have so many people that are attending today that are familiar and can appreciate the sophistication of your work here. I'm a fan because of understanding, seeing the maps that you've created. And I really encourage everyone to hop over to the digital gallery at some point to see some of the exhibit that you created with Tom that gives our members special access to see these beautiful maps you've done. And also, of course, there's Muirway, and you've got amazing video on your Twitter handle as well. So we're just delighted you were here with us today and sharing some of this amazing technological aspects of creating what is so incredibly beautiful to us and helping us understand. I'm going to stop talking and open the floor to questions. I'm going to switch us to, I don't know, Sean, if you want to stop sharing for 1 second, I'm going to put us on gallery view so I can
absolutely
see everybody in case there's hand raised or people can just unmute and ask a question. Wow, I'm kind of blown away.
So we had a question from Doug Olcott. Flying to capture ortho rectified imagery is expensive. Is your company using drones yet in this effort?
I have not. Sorry, let me get my thoughts together here. They do in very limited areas. We generally specialize in capturing large areas. Say like we just recently flew the levees of New Orleans. I put an animation of that. Actually, I made a 3D animation of us flying the levees of New Orleans on my Twitter. We recently flew those for inspection. That's not something that you could easily capture with a drone quickly. Most everything we do is pretty large scale, where a drone is not feasible. But we do have some areas in the company. I've only dealt very sparsely with drone data. I mostly deal with imagery that's captured from either helicopter or fixed wing plane. But we do, in a very limited capacity, use drones.
See Jim's hand?
Sean, could you summarize the kind of hardware you're running on?
Let's see here. I always forget what the name of my processor is here. All right, so I've got an AMD Ryzen 9 5900X 12-core processor, a RTX 3080, and 128 gigabytes of RAM. I'm hoping to get a second 3080 in here soon so that I can render a little quicker.
That's very powerful stuff.
It's a pretty beefy machine. It does me well.
Tom, do you want to screen share the digital gallery so people can see,
Sure.
you know, these beautiful things that Sean has created? And I'll put the link in.
So this is the exhibit. It's 173. I actually, let me see where it is on the homepage here. Why am I not seeing it?
It's at the bottom right.
Oh, bottom right. I'll probably move it up to the upper left here after we're done here.
If anybody's interested, that first picture there, the first slide is the Isle of Iran, and that was made using LiDAR data.
So I'm just going to tick through it.
See, he added the clouds on that last one. It's just such beautiful imagery. Look at that, it's just stunning. And you can zoom in on the digital gallery to be able to zoom in and see it.
Here's Italy. This was.
And Sean, you did not give these a full resolution. So you're looking at these and stunning as they are, they're not even at the fullest capable resolution. So we're pretty amazed.
Correct. Like say this Guam one that I just recently showed you, I am now looking at it on my screen. It's 10,000 by 13,000 pixels. So they can get up there in resolution.
That's like double. I think these ones were 4,000 or something like that on a side.
I believe so, yeah.
And here's Hawaii, 3 different ways with clouds and then with the bathymetry. Bathymetry, yeah, or topobathy if they're both together. If you see the land and the ocean there. And then, oh, this is Kenya. This will probably explain the Erie Canal with this map.
New York was actually one of the first ones I put clouds in. I was very happy with how they came out.
Yeah, that Kenya map is fascinating. In fact, it'd be great to do it for all the Rift Valley throughout all of East Africa, because much of human migration is determined by what's going on there.
And again, this is where we're really lying with the map here. Of course, if you looked at the United States at its standard resolution or at a standard elevation, it would look pretty flat at that size. So I greatly had to exaggerate the Z values on it.
This is the Imhoff map, which he's the pioneer in this space, right?
He specifically pioneered, this map doesn't seem to really highlight it, but he did pioneer in his colors. using really warm colors and lighting in the peaks, especially in where there's high mountains, but then in the valleys using washed out blues and cooler colors. There's actually, again, another person who's great to follow, a modern cartographer, John Nelson. He works for Esri, who makes the ArcGIS software. And John Nelson does a lot of tutorials for people who use ArcGIS Pro. And he actually did a full tutorial on how to get Imhof's color schemes into ArcGIS Pro to make Imhof-like maps. I mean, Imhof was doing this in the early 1900s. I think he just passed away just as recently as the 80s. But that's how long of lasting, effect he had on cartography that we're still wanting to emulate his map style in modern software.
This was the one that.
Did I give you the one with the bathymetry on that one?
I don't think so.
Oh, I'm so sorry about that. I did two versions of this map, one with topography and then one with topobathy, so that you see the ocean floor also. But again, you can visit my Twitter or my Instagram and it's on there.
These are the Ural Mountains on the right, I think. This is awesome.
Have you ever considered doing anything? I think NASA has made some of the digital elevation data from Mars publicly available.
I've done Olympus Mons. That's actually what was on the cover of the Rulesian trade publication. That was a long time ago when I was first learning this. Actually, I'd really like to go back and do it. I think I could get out more detail, make it look a little bit better.
Awesome.
But yeah, I've done Olympus Mons. I've done a few of the moon.
I see Dan and Ron both have their hands up. Ron,
I'll
would you
jump
like
in
to-
quickly.
Oh, Diane, thanks.
Yeah, I was just going to ask if any of your maps have been published as image tile services that could be pulled into ArcGIS Online. Is that even a thing? I don't know if I've seen georeferenced historic maps brought in that platform.
None of mine have. The Rumsey collection, which I saw was as a link there that Tom had in the gallery. They have a georeferencing program where I think they let their users georeference the maps. I don't think they offer it as an imagery service through ArcGIS, but they do have georeference historic maps on there. Although I georeference my maps to create them, when I'm done with them, they're obviously no longer georeferenced. What I'm getting back out is a regular TIFF. And one thing that sometimes the georeferencing distorts the map, and I have to post-process it in Photoshop to straighten it back out, which means that if I wanted to georeference it, I'd have to re-georeference it, and then it would probably reinstate the distortion again. So the map wouldn't look exactly right if I did re-georeference it, but it is something that I've considered before, at least for some maps, like say the USGS maps that are almost exactly right to begin with. They're not super historic, they're just from the 1900s, so they're pretty accurate. So if I re-georeference them even with the 3D terrain in there, it would look fine. And then I could host it on a service, but it's not something that I've done yet.
Ron, did you have a question?
Sean, really fascinating. I was interested in city maps. You said that you had done Manhattan. What can you do where the topography of a city has changed over the course of 100 or 200 years? Hills are flattened and swamps are filled. Can you really go back and get earlier topographic maps?
The maps themselves, I always work with vintage maps, but I only apply modern elevation data. So you will see, sometimes jarringly, the differences between them in the map. You'll see, like I said about the Netherlands, land reclamation that wasn't there when the map was created, or in the Manhattan one, the building footprints and the shadows from the building kind of hide it, but you'll see the original building footprints that were in the map, and they weren't nearly as dense or as populated as it was with the modern footprints in there. So there's really not a whole lot I can do to change the modern elevation data to match the historic map. But sometimes that's what people like to see is the difference that you can see between the historic map with it layered with this modern topology.
Right, and how far back did the earliest topographic maps go?
I mean,
1870s.
I'm sorry.
1870.
Yeah, I
think
mean,
it's the 1870s. I mean, the USGS began it systematically after that, after Powell.
1870s, Tom?
I think so, but I've got to check with my brother, who's the geologist. I mean, he basically.
But hashing was a thing on map for a long time, right? Just
right.
And I think, Ron, what you're getting at is that Manhattan used to be a city with serious elevation in it, and not, it's all been lopped out. It would be interesting to see that somehow rendered.
So did Boston. I mean, the whole of Back Bay in Boston is filled from a hill that was leveled, and Beacon Hill.
But you can actually, I don't know if, I don't think I gave Tom the link to put on there, but for the USGS maps, there's a website called TopoView, and they've got scans of just about every USGS quarter quad map or larger that they've ever done.
Yeah,
and some of them do go back to the late 1800s.
They do.
I have a map of California from the USGS. It's in the 1850s. So it goes back a lot further.
Oh, absolutely.
Sean, have you tried working with any Army Map Service products?
Some of the USGS maps are actually updates of Army Map Service maps, well, Corps of Engineer maps that they just used as topographic maps now. But otherwise, not really. Like I said, I did do one of the landing at Normandy. I found that on the Library of Congress website. But otherwise, I've not really done much like that.
I was thinking of Southeast Asia, particularly Vietnam. A lot of the really detailed cartography is still classified.
Yes, and they do release, there's rolling releases on classified maps, like from the CIA. The University of Texas, I believe, has a map library, and they have several Army Map Service maps on there, and they are very detailed. One thing that I try to keep in mind, since I'm doing this more for aesthetics and things like that, is vintage map borders. I found that some people can get very offended by the changes in borders. If I do a map that has a border from, say, the 40s or 50s that's changed since then, they don't like to see those old borders. And I fully understand that this is something cultural. There's very good reason for them to not want to see borders that could bring up memories that they don't want to really think about. So that's one thing that I try to think about when I go back to those old maps in Asia, or especially the Middle East.
Thank you.
That's wonderful. Well, I just want to take a moment to thank again our amazing three presenters, Stephanie Kirchie, Andrew Frank, and Sean Conway, for their diverse topics today and very interesting ways of both using maps to teach, to inform, to enlighten us, and also how maps are driving some of their research and understanding of the topics that are of interest to them. I think we all give them a round of applause in our way we can do it on Zoom. And I just want to say thank you so much for attending the California Map Society Fall Conference. If anyone's interested in joining us, you can go to our website, www.californiamapsociety.org. On the front page, there's a place where you can join or even gift a membership if you're interested. And we hope to see you at a future conference or activity or event coming up. Thank you again for attending, and we look forward to seeing you soon.
Thank you. Thank you, Courtney.
Courtney,
thanks everybody.
Speakers, thank you. Great breadth from the 18th to the 21st century. Have a good rest of the weekend.
Thank you, everybody. Have a good weekend.